MRI briefly is a diagnostic imaging modality that uses a powerful magnet and RF pulses to obtain detailed images of organs and tissue throughout the human body. The magnet used in MRI device is a superconducting magnet, which means it is a powerful, high-strength magnet that is produced by passing a high-intensity electrical current through a group of coils of wires. These wires are called superconducting wires. What is the meaning of superconducting wires? These are wires which are made of material that when exposed to a very low temperature, critical cryogenic temperature, it will go into a state of transmission and supporting of passage of high-intensity electrical current without resistance, without heat, and without loss of energy, which means we are obtaining a closed circuit electrical current which will last for years without change or alteration, and we can even separate the power supply from it. All this process is immersed in a very freezing liquid helium that you hear about, and this temperature that would make this material superconductor is 269 negative centigrade. Imagine how much the coldness to reach this level. And this assembly together is installed in a vacuum sealed enclosure which is around the table of the patient as we see in the previous image. The gantry which surround the patient table and the bore of the magnet is filled with this material and which will act as a superconductive magnet, which is static magnet and constant magnet. This is a brief idea about the principle. What I want to get from this idea is we are dealing with the first component that makes hazard, which is a very, very, very strong magnet, and the second one is the RF pulses that we use to produce the image. Simply, we transmit these radio waves into the human body, the body absorbs it and emit it again to a computer system which will produce signal. So we have these two components, and we will further discuss how they make hazard on the patient and other possible objects. The next question, which is related to our talk, is how strong is the MRI magnet? And the answer will be by comparing this magnet strength to the Earth magnet strength at Earth's surface. And our magnet, which is 1.5 Tesla magnet, the unit of measuring the strength of magnet, equals 33,000 times more potent than the Earth's magnet strength at the Earth's surface. Imagine how we are dealing with such high strength magnet in a closed area where patient can't move and the staff are available and a lot of equipments are present. And of course, if we are talking about a 3 Tesla, it will duplicate, and if we go out the range of diagnostic range, we will have amazing number of markedly strength magnet field. And of course, by knowing this strength of the magnet, we have two effects on objects. The first effect is attracting and pulling these objects, which I mean made of iron or other ferromagnetic material, by a sudden, high force, high speed projectile or missile pattern into the bore of the magnet. Thus, anything along this flight path definitely will be harmfully and severely injured, include patient, of course, which is our priority. It might lead to a deadly accident and severe injury. The force of projectile effect, you cannot imagine it. 1 second, you will see this object is flying and going into the magnet bore. The second type of effect which this magnet could hazard objects and materials is the damage and malfunction to multiple medical devices which are external or internal in the human body. Examples: aneurysms, clips, medications, pumps, insulin, and etc., pacemakers, electrical and neurotransmitters or simulators, VP shunts, heart valves, or etc. To be honest with you, these factors are absolutely contraindicated for a while, but nowadays they are making MRI compatible pieces or devices or medical equipment which have minimal ferromagnetic component, and we are transferring to call them conditional, and if you call the engineer which is responsible for this device, he will manipulate it during the examination, and it becomes no contraindication for MRI. I'm talking in history, but if we go back, if the patient has this device previously, we can't guarantee the content of it. And it should be treated or dealt with as it is highly risky material for MRI examination. Next question is, how safe is MRI? The answer for this question is by uploading these images. I upload these images from true life accidents through imaging of MRI patient. The first image is a pulled large oxygen cylinder which is squeezing and pressing the patient in the entry of the magnet bore, and the assistants and accompanying are trying hardly to save, which is not applicable. They will go into something else which is we'll call later, which is a quenching and immediately terminating the magnet to save his life. The second is, luckily no patient is there. Look at this small oxygen cylinder which is hanging and fixed into the wall of the magnet bore. Imagine this bit is going as a bullet or a projectile material attached to the bore of the magnet, and imagine this chair hanging in the front of the magnet bore, and also this wheelchair and this cleaning trolley that could be present in the area. What I mean in all these items that I mentioned here are always present and available in the atmosphere and environment of MRI. So it can happen if we don't follow the safety guidelines and parameters. I witnessed one of these accidents in my previous work, a small, luckily it was a small oxygen cylinder, and this is what I'm saying, you can't imagine the speed that this metal went into the bore. Luckily, we are at the early stage of the imaging, and by mistake the staff approaches deeper into the unit, and it goes like a missile into the bore. Now our main question to be answered, after knowing the hazard and the main components that will exert hazard on patients, how can we ensure patient safety in MRI? And of course the answer immediately will be by strictly applying and commitment and adherence to the guidelines and standardization that we put for MRI work. And let's go through some of these guidelines. I will mention mainly the guidelines regarding the environment of MRI, which includes the MRI unit and the surrounding surface area, and including the staff, workers, doctors, patient, and equipment. Of course, we are following the parameters and guidelines of the RPD in this manner. This is, by the way, the images are taken from our department, which I'm proud of, and I think it fits fully the safety parameters, so I can put it and show it to you safely and with ease. This is the zonal division of the MRI environment. Zone 1 is marked as the green zone. It is outside the MRI environment. It is the public safe zone where patients, staff, anybody can walk freely without supervision or guidance. This is a free zone that is permitted, but it alarms you that you are approaching an area of danger, which is the MRI unit. The second zone is the zone between the public safe zone and the third restricted zone. This zone is the zone of examination, greeting the patient, preparation, taking parameters of the patient weight and height, and documentation of the patient data and the clinical history. In this zone, we have a nurse and a level 1 radiographer. What is the meaning of level 1 radiographer? It is a radiographer which has adequate information about safety of MRI, including contraindications and things that the patient should eliminate from his belongings and clothes. In this area, we have the recovery room, we have the desk for signing and taking the history. Also, in this area, we perform our handheld metal detector. After the patient changes his clothes in the changing room, he comes, full questionnaire is done, and the patient should read it carefully, and he should sign by yes or no every item on the questionnaire. And by filling this, the patient himself and the radiographer will sign on the form. And this is stage of signing in front of the nurse. And after clearance from this area, the patient is to be transferred to the third zone, which is the zone after clearance, we call it. And at this stage, radiographer level 2 takes the care of the patient, which is a radiographer with detailed knowledge about safety of MRI, operating MRI machine, and know how to deal with emergencies. I emphasize on this point. He should know how to deal with MRI emergencies. And in this zone, we have our distinguishers, we have our control room, we have our free exit and to the MRI room, which is the zone 4. This is the inlet or door of zone 4, which we see the signs fully listed on the door, and we have an extra electronic detector and alarming device. If the patient, we by mistake forget to detect something which is small, not harmful, it will show up and make our attention to that area. This is our MRI machine, which is the room area, and it is called zone 4. And in this particular zone form, the patient is supervised, body-to-body supervised by the radiographer level 2, with instructions to the examination and instructions how it takes long and what he will do. And in that case, the radiographer should take care of the second type of hazard, that is the radio frequency. He should not make the patient touch the coils or the bore of the MRI. He should remove the clothes. Of course, if there is an extra clothes that he knows that is sporty clothes that would heat with the RF frequency. By the way, the FDA report for the types of hazard in MRI patients had classified heat and burn as number 1 due to the RF, the radio frequency energy, and second is the projectile damage, and the third is the alteration or damage or malfunction of implanted medical devices. Quickly, we have the signs in MRI. This is the sign that I demonstrate first. Every visitor to the MR unit will see this type of marcation of prohibited and allowed material. All of them are clear in an image and writing. This is a list of contraindication of MRI. We classify them into 3 groups. One is certain and absolute contraindication, which applicable to each age with advance. From these are the pacemaker, implanted defibrillators, vascular eclipse, external implanted medications, cochlear implants, neurostimulators, catheters with metallic, bullet, shrapnel, metallic fragments, metallic foreign body, and external fixation. Some other contraindications are the wallet, credit cards, and magnetic strips. This will be dysfunctioning. The prevention or prohibition is for dysfunctioning. It will not act after leaving the MRI room. External hearing aids, devices as beepers, phones, watches, pens, and coins. For the woman, the makeup, it will heat with the magnet field and should be removed. And the third is type of contraindications that will, not absolute, but we take in consideration they will affect the quality of the image. Joint replacement, prosthesis, internal fixation rods of the spine, metallic jewelry, tattoos will heat with MRI, because of metal component in the pen and or the ink, makeup, and dental fillings. The last thing I would mention about MRI, the correct saying that the most hazardous point of MRI is not the magnet, not the RF, it is the inadequate education of the staff and facilities and visitors for the MRI unit. We keep training our personnel by attending trains and dawrat. Luckily, in the next week, we are invited the MRI team for a workshop on the latest advanced ACR hazard and safety guidelines at Dar al-Shifa on the 2nd of August, and definitely it will enrich our knowledge about the safety. Thank you for listening, and I hope it was useful talk.